Hello everyone, and welcome back to our channel. Today, we have an exciting topic to dive into, microservice architecture. In this video, we will explore the ins and outs of this modern approach to software development, understand its benefits. So, let's get started. To begin, let's define what microservice architecture is. Microservice architecture is a design pattern that structures an application as a collection of small, autonomous services. Each service focuses on performing a specific business capability and communicates with other services through lightweight mechanisms, typically via APIs. Unlike monolithic applications, which are tightly coupled and have a single code base, microservices can be developed, deployed, and scaled independently. Key characteristics of microservice architecture. Service independence. Each microservice operates independently of others, having its own database and code base. This isolation enhances fault tolerance and allows teams to work on different services simultaneously. Decentralized data management. Data is distributed among multiple services, with each service managing its own database. This decentralization promotes scalability and resilience. Polyglot technology stack. Microservices offer flexibility in technology choices, allowing teams to use different programming languages, frameworks, and data storage solutions based on specific service requirements. Service communication. Services communicate with each other through well-defined APIs, often using lightweight protocols such as HTTP REST or messaging systems like RabbitMQ or Apache Kafka. Scalability. Microservices can be individually scaled based on demand, enabling efficient resource utilization and high-performance applications. Benefits of microservice architecture. Agility and flexibility. Microservices enable organizations to embrace agile methodologies and respond quickly to changing business requirements. Services can be developed, deployed, and updated independently without impacting the entire system. Improved scalability. With the ability to scale individual services, microservices facilitate horizontal scalability, ensuring optimal resource utilization and cost-effectiveness. Fault isolation and resilience. Failure of one service does not bring down the entire application. The fault is contained within the service, allowing other services to continue functioning. Technology heterogeneity. Microservices accommodate diverse technology stacks, enabling teams to choose the most suitable tools for each service, enhancing innovation and productivity. Team autonomy. Microservices align well with DevOps and empower cross-functional teams to work autonomously on individual services, fostering faster development cycles and ownership. Challenges and considerations. Service coordination. As the number of services grows, managing inter-service communication and ensuring consistency becomes complex. Implementing robust service discovery and event-driven architectures can help mitigate this challenge. Data management. Microservices demand careful consideration of data consistency, as data is distributed among multiple services. Techniques like event sourcing, command query responsibility segregation, and distributed transactions can address these concerns. Operational complexity. Microservices introduce operational overhead, requiring mature deployment, monitoring, and orchestration practices. Adopting containerization and container orchestration platforms like Kubernetes can simplify management. Testing and debugging. Testing distributed systems and identifying issues in microservices can be challenging. Implementing comprehensive testing strategies, contract testing, and distributed tracing can aid in effective debugging and quality assurance. Best practices for microservice architecture. Design small, focused services, keep services granular, focusing on a single business capability, and avoid bloated or overlapping services. Establish clear service boundaries. Define well-defined APIs and communication contracts to facilitate loose coupling and service independence. Adopt containerization. Use containerization technologies like Docker to package and deploy microservices consistently across different environments. Containers provide isolation, portability, and efficient resource utilization. Embrace automation, leverage continuous integration and continuous deployment, CI/CD, pipelines to automate the build, testing, and deployment processes. Automation ensures faster and error-free service delivery. Implement service discovery and orchestration, employ service discovery mechanisms, such as Netflix Eureka or HashiCorp Console, to dynamically locate and manage services. Additionally, adopt orchestration tools like Kubernetes or Docker Swarm to automate service deployment, scaling, and resilience. Use asynchronous communication, when possible. Prefer asynchronous messaging patterns such as publish/subscribe or message queues to decouple services and handle high loads efficiently. Monitor and trace services, implement comprehensive monitoring and logging mechanisms to gain insights into the performance, availability, and behavior of microservices. Utilize distributed tracing tools like Jaeger or Zipkin to track requests across services and identify bottlenecks. Implement circuit breaker and retry mechanisms, to handle failures gracefully. Incorporate circuit breakers and retry mechanisms in service-to-service communication. This helps prevent cascading failures and improves overall system resilience. Security and access control, apply security measures like authentication, authorization, and encryption at the service level to protect sensitive data and ensure secure communication between services. Plan for failure, design services with the assumption that failures will occur. Implement strategies such as timeouts, retries, and circuit breakers to handle service unavailability or degraded performance. Use cases of microservice architecture. Microservice architecture is well suited for complex and scalable applications, including but not limited to e-commerce platforms. Microservices enable the independent development and scaling of services such as inventory management, payment processing, order fulfillment, and recommendation engines. Financial systems. Microservices provide a modular approach for building banking systems, payment gateways, fraud detection, and account management services. Content management systems. Services for content creation, storage, search, and delivery can be decoupled and independently managed using microservices. Internet of Things, IoT, applications. Microservices enable the integration of various IoT components, such as sensors, gateways, and data processing services, facilitating real-time data analysis and decision-making. On-demand services, applications like ride-sharing, food delivery, or travel booking can leverage microservices to manage user profiles, location services, payments, and logistics. And there you have it. A comprehensive overview of microservice architecture, its benefits, challenges, and best practices. While microservices offer tremendous advantages in terms of scalability, flexibility, and agility, they also require careful planning and consideration of various factors. By following best practices and understanding the trade-offs, you can harness the power of microservices and build robust, scalable applications. Thank you all for watching. If you found this video helpful, please like and subscribe to our channel for more exciting content. And don't forget to leave any questions or suggestions in the comments section below. Until next time, happy coding!